to our ALU, we added a painting mode. So we have this big case statement here, and inside of it, they each have if-else statements. This is the representation for red. This is a representation for green, and this one for blue. And then depending on the value of B, whether or not it also is red, green, or blue, it'll then either mix the colors or just send back the original color if in the event that they're both the same. So then moving on to the 7-segment display, depending on the result sent back from the ALU, it'll then either, this is the mode for the hex display. So if it is red, it will then set the appropriate variables to display the hex representation of red, green, blue, yellow, purple, and cyan. Then below here, we have another mode that does the same case statement, but instead assigns different values because this is our alphabetical mode. So this would then display the letters for red, green, blue, yellow, purple, and cyan. As you can see, also our default statement is in both of the case statements here, and that just default displays the error message. It just writes out error. We scroll all the way down here. We added to our hex encoding list. So from here downward, represented the typical 0 to F representation for the hex display. And we just added a couple letters that we needed for our own particular spelling of the colors. So
for our VGA display, the way it works is we take in 3 inputs. We have a clock, a reset button, and the 4 switches that determine what color we're displaying on the 7-segment and on the screen. And then we're going to output either the red, green, or blue, and then the horizontal vector and the vertical vector. And so the main thing that it does is we first create the 2 squares that we overlap over each other, so we can mix the colors that way, depending on what color we choose each square to be. And so the way we do it, we have a big case statement where depending on what the 4 switches are turned on to, for example, this one is turned on to show red, we assign the first square to just be red. And then we have this for each combination of colors. So we want to mix the colors. For example, with this combination 1010, we assign both squares. This one is assigned to red, and this one is assigned to green. And so red plus green will give us yellow. And then for purple, red plus blue will give us purple. And finally, for cyan, with the combination 1011, we assign green, blue, and it gives us cyan.
So for our lab 3, we added what's called a painting mode. So now we can choose a color to display with the switches, and it can either spell them in alphabetical or in hex, depending on what mode we are in. It's going to display it on the VGA. So if I turn on painting mode and alphabetical mode, I can start to switch on the colors. So I can say, this says red, so it shows red here. And if I switch it on to hex, that's red in hex. Now if I do this, it's going to give me green, and I can say that's green in hex. I can also do blue, and blue in hex. Then I can say yellow, and yellow in hex.
This doesn't work.
I can say
at least we know it worked before.
Purple, purple in hex. And finally, we can represent
4 bits. You would have okay. That should be
cyan, and then cyan and hex. So we can switch between mixing the colors into 6 different colors, and then we can switch the V7 segment to read the colors either in hex or in alphabetical.
So to begin our project, we were a little bit overly ambitious. We were attempting to have keyboard input into our FPGA, but we quickly found without a PS2 input that it was going to be pretty difficult to learn in the given amount of time. So we ended up scrapping that idea, but we have this leftover module here of a key to ASCII that would have converted the key input into an ASCII equivalent that then we could have used in our FPGA and ALU to convert into different values.
For our VGA, Initially we had a lot of trouble getting it to display on the screen. So we had to do some troubleshooting. We had to use some different code from online and stitch it together. But eventually we were able to get it to display on the screen. We also had a little trouble when we were implementing our VGA into our system as a whole. We had to make sure we were passing the right inputs to it, and we had to make sure that the outputs lined up to the original VGA. So for the system itself, the way it works is we overlap two squares, and we can change the color of each square to get one of the 6 combinations. And so that's how we're able to go into painting mode and create the different colors.